Welcome to another episode in our ESP32 Adventures, and in this episode we are going to connect the keyboards to the ESP32-S3 boards and see if we can get input keystrokes from the keyboards and if we can operate on them and stuff like that. And we're going to start using the Espressif ESP32-S3-USB-OTG boards. Quite a mouthful, I know. Okay, so let's get rid of this text here. First of all, you might remember from previous episodes that this particular board is ESP32-S3-USB-OTG board. It has a bunch of built-in switches. Some of the cheaper boards, they will do it via jumpers that you'd have to solder and so on. But this one makes it convenient. You can switch things over in software. And there are two signals, boost enable and dev vbus enable, which you would select in order to select where the power for the host port is going to come from. It can come from the USB dev port, which you might remember is the male USB-A plug, and the host is the female USB-A plug, of course. So you can power it from there, or you can power it from the battery, which is what we're going to be doing today. Or you can set them both to 0, then there is no output on that host port at all. So in other words, you're not using host mode. And in addition to that, there is a current limiting switch, which you would also want to use because you want to limit the host outputs to 500 milliamps. We don't want it to blow fuses. And that's a signal called IDEV limit enable. So, in one of our previous episodes, we found out that these boards have folders in platform I/O, and so in the previous episodes, reset. So in previous episodes, we found out that there are files in folders used by platform I/O that actually have information about the pins, and in this case there is a variant as well, and it is all, you will find them in users, and now info over here, that is my username. You know how it is. Some years ago, Microsoft insisted that you had to have a Microsoft account, and I didn't want them to have my personal email address, so I made one up called info at my domain, and it was info at da 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 da, so I became info. So in your computer, that will be your username, whatever you use in order to log into your computer with Microsoft accounts or whatever. Then there's DOTS platform I/O, packages, framework, Arduino, Espressif 32, because we have 32 ESP32 boards we're dealing with. Then there's a folder called variants, and then in there is actually a whole bunch of different board names, and we are using ESP32-S3-USB-OTG. So you'll find two files in there, pins and variants. And what you will find in there is the pins file. And you ever wondered, I did in the past, and I didn't actually investigate it, but when some boards, they have like pins like D0 and A0 and so on, and mostly like the old Arduino ones, and other boards don't have that. You just got to put in the GPIO numbers, and this is where that's done. This is in the pins underline Arduino 8 file, and the Arduino IDE has something similar, but they put the files in a different place, and I can't remember offhand where that is, but I don't use the Arduino IDE much anymore, so I'm not too worried about that. I use Platform.io. Anyway, so here you see there is a bunch of stuff that they are. This is the ID of the ESP32-S3 boards. That seems to be common to most of them. And there is some information about how many interrupts it can have, how many digital pins, how many analog inputs, and so on and so on. And here is some the TX and RX pins, 43 and 44. So if you want to hook up use it as a UART or something, those pins you can use, and so on. And there's some I squared C, I squared C. So there is some I squared C pins, some SPI pins, and here are some analog pins, A0, A1, A2, connected to pin 1, 2, and 3, and so on. But what we're actually interested in is, in the last one of the few previous episodes, we used those SDMMC pins for accessing the SD card slot. We have used, and we are still using, the LCD, and these are the LCD pins. And then there's buttons, LEDs, board controls, and these are the ones that we're interested in today. Dev VBus enable, boost enable, limit enable, and USB host enable. And there's a couple of pins that you can actually use. You can read if it is trying to draw too much current in the host port, and you can measure the volts. We've used those in a previous episode. And here, actually, I was wondering when I did the previous episode, I didn't know, but this is actually tells you to get the voltage. You take the value that you read from there and you multiply it by 3.7 for the host, and for the battery you multiply it by 2. I kind of did that experimentally and created a value for that, but I must check that out in future, see if that is how well that works. So there are USB ports, pins 19 and 20, D minus and D plus, and of course there are some JTAG debug things on the bottom. They're like pads. I'm not using those. But what is interesting is that there is another file here which it has previews for, and there is a type def enum here. You can choose to turn the USB host power off. You can choose to use host power from the VBus, or you can use host power for the battery. And that comes together if you look at this variant file. Now I've edited this a little bit. I don't know why those C++ and JavaScript jockeys like to have their curly braces at the end here, and they will put it in the front of else, and it just makes the code unreadable. Same here. So I've opened it up a bit and reformatted it so it's much easier to see. So there is a function here, USB host power, that I put those comments on there myself so that when I use it I can actually see. And you will pass in the mode, and it will actually adjust those pins, USB host power and BAT and all that kind of thing for you. And there is a USB host enable that you can pass true and false to, and then there is a NIP variant which I have also put in my code. I don't know if this thing is called elsewhere, but I'm using it just in case, and it actually enables all those pins that we need, so we don't have to do it in our code. And if we look over at the main code over here, you'll see me using that, the setup, I do use a few other pins for the buttons and the menu buttons and the LEDs potentially. Actually, I'm not using LEDs right now here, but I got those in there by default. I put some comments in here where those files are coming from, varying CPP and pins to remind me in future. And you see I put in there your user ID. Eventually, some of this code is going to end up in a couple of future episodes when we actually going to do projects. I will put the code on GitHub or some other place, and you'll be able to share it with you. But so that will become useful to have these comments in there. So I say, okay, init variant, select the USB host power from the battery, and enable the host out input, and then I set up the TFT display so I can put messages on there. USB host started, make sure you connect the battery and switch it on to power the keyboard. And then there is very little else. I'm not using this button press thing right now yet. I might. This is actually just test code, and I might in the future. I don't know, but and all you do is USB host task. Now, where this comes from is I found a library written by a Japanese chap, Tanakama Sayuki, and he had a library on the GitHub, but what I've actually done is I've started editing it, and I'll be making more edits to it. It was lacking some functionality that I needed, and I have actually put those files in. I put the header file in the includes portion of the project, and I put the CPP file in the source section of the project. So back to main, and up here the way it works is after you start the USB host task, it will actually come back with a callback on keyboard key, and it will give you you create a class from my ESP USB hosts, and you will public USB. Of course, you can call that anything. In future, I will rename that, of course, but that's the default test program had that in there. I've left it alone. It's fine. So there's a callback there on keyboard key, and you are handed once a key is pressed on the keyboard, you are given the ASCII code, if any, that it belongs to. So if you hit like the A key, there will be an ASCII A in there that you can display, and we're doing that over here. And then we have the actual key code, which is the HID human interface device key code, and we have the flags, the bits for the modifier, which is Alt, Shift, and Control. So what we display then on our little LED display built into the board is first we format it into a variable here. I've declared a bunch of variables up here. Not very elegant, but as I said, it's just some test codes. We'll get back to that in a second. Okay, so we then display, we format the text here, key, and we'll give the integer value and the hexadecimal value of the key code, the modifiers, the hexadecimal value and the decimal value, the actual character that was returned, either as a character and also as a hexadecimal value, and then we will show whether it is Shift, Alt or Control was in that modifier, and there is some functions there like has Shift, has Alt. It just checks whether that bit is set, and has Control. And I actually created a little method in here, or a function if you want to call it that, to translate HID code into a string. So like for instance, if you hit F1, I want to see F1. If you hit caps, I want to see caps. If you hit enter, I want to see enter. And then I can actually say name, and I put the key string there, and that's actually done over here. This is a full set just about of all the HID keys. This actually came from the this file over here, which is actually built into, by the looks of it, that's built into the ESP32 section of I don't even know where is that. It's actually located in users, my username, platform, my packages, framework, Arduino, Espressif 32 tools, SDK, ESP32-S3, include Arduino, tiny USB source, class, HID, H. Boy, it's a long way, but that, as I said, it comes part of the package of the Espressif 32 stuff. So it's not something you have to import. You can just refer to it. And in there is all the key codes that are known. So I just copied those and I put them in here. I'm not processing some of them, which is interesting. We're going to have a look at what some of these keyboards do. We'll have a look at that. It's kind of interesting because the little test application that I've got here, you can actually use it, plug a keyboard into it and see what codes your keyboard comes back with. It's kind of useful for that even. So, but in any case, I've got a switch here. I take the HID code, and if it's enter, then I return enter. If it's backspace, I return backspace. Actually, I'm going to change that because the key has actually that on it. So I might as well make it the same as the key. Tab, caps, F1, print screen, scroll, log, pause, in home, page up, delete, and so on. And if it is any of the other ones, I return NA. You can make out that that's not applicable or not available. You can choose what that means. So that is the only code in here. And as I said, we look for libraries that do the heavy lifting for you, and that leaves you with as little to do as possible. Now this particular thing here, I will be moving that. I'll be that's one of the reasons I took this code. See, he's got some code in here. Since he is Japanese, he's defined his own a secondary HID code to ASCII table for Japanese, and it's got hiragana and katakana and what have you stuff in it, I guess. So I'll be looking at that. I'll be removing that because I have no use for Japanese stuff. And so that's going to be living in here and in here when I get to finalize those. But right now I haven't touched these. I've left them as they are. And this is the little board. I've plugged in the battery over here, so I can actually turn the battery on, and there it is. It's going to be running. we are also going to be trying this stuff with these guys here. This is the DevKit C1 clone. It has 2 USB ports on there, so it should work. But this one over here, we'll actually be using this messy looking one over here, because there's a little switch on the bottom here which is marked OTG. So I don't know what I'm going to find, whether I need to switch that on or off. Probably, because that OTG feature is what makes that host port work. But on this one it is much easier because it's done in software, as you could see. This one here doesn't have anything like that, and it's only got 1 port, but it does have an S3 chip on it. So it's going to be interesting to see what this one does. I have no clue, but it also has a battery socket on it, so we're going to be trying to run this one off a battery and upload some code to it and see if it will take keyboard input. I don't know what I'm going to find, but we will look at it. Alright, so let's bring in the other camera here. So here is one of my little keyboards. I tend to like using these little keyboards nowadays. This one, though, I couldn't use for the very simple reason that when I'm editing source code, I need a home and end key, and this one only has insert, delete, page up and page down. So, and I could not modify any of those keys. Now there is some software out there that you can get, like auto hotkey and so on, that might have been able to do it, but this is what spurred me to try this project, these kind of projects, to find out how this USB stuff works, because I would like to make a little dongle with one of these little things in it, or maybe even one of those, but there are smaller ones that you can get, and to be able to plug into these keyboards and intercept the key codes, and then maybe if I hit Alt, Control, Escape or something, maybe I'll turn that into home or switch modes or whatever. You can do anything. You'd be able to make up a little interface in order to program it, whatever, using the microcontroller. So this is some of the things that I'm thinking of and doing in the future, and that's why I'm investigating all this stuff, to teach myself what is available in libraries and how it all works. Anyway, let's have a look now. We need a USB-C cable. Yeah, this one will work here. So if I plug this one into the host port, and this keyboard uses a USB-C cable. Oh, this is not the right cable. This is not USB-C. What am I doing? That's better. This is a USB-C. Okay. So I'm going to plug it in. Okay, so we see the keyboard is actually responding. It's powered. I don't know how much these backlighting drains, so let's turn it off. Alright, so there it is. Let me see if I can zoom in a little bit so you can see what is being displayed. Okay, let's adjust the camera a little bit. For some reason, these little cheap cameras that I get from AliExpress, the background is actually black, but it kind of looks blue, and then it goes jittery on me, so I reduce the input contrast. Anyway, okay, so this is the A key, and indeed we know that is code 4. We've looked at that before in our previous episodes. and there's no modifiers. It's the ASCII code is 61 hex and it's lowercase a. 41 hex would be uppercase. So if I hit Shift A, there we go. Now it's uppercase A. The key code is still 4 because it's still an A. But now there is a modifier, as you can see, 1 hexadecimal, so it's bit 0 is the Shift key. So Shift yes, Alt no, Control no, and name not applicable. It's just a letter key. So if I hit Escape, for instance, you can see its code and what have you, and it is actually 1BH, which is I think that's 27 decimal, if I remember correctly, which is indeed the escape key code, and the name is Escape. Now, interestingly enough, the Win key on none of these boards seems to return anything. I don't know why. I don't know if this is a limitation of the library I'm using. I must investigate that. And similarly, some of the other keys like paused, but this one doesn't have it, don't seem to do anything, but nevertheless, you can see backspace. I edited that earlier in the code, but I haven't uploaded it, so it still says backspace in full. This is insert, delete, page up, page down, arrow keys up, down, left, right, and if you go Control, Alt, Shift, and hit something, then it's key 29, 1D hex, modifier 7, and I think that is actually like an ASCII code for like backspace or something. But sure, let's hit something else. Huh, interesting. I must have a look at the code when I hit Shift, Control, Alt. It doesn't come back with a the character line seems to be blanked out. I must have a look at that. Could be that there's some bugs in that library. I must have a look at it. I mean, I've downloaded it from this chap Tanamaki, whatever his name was. Anyways, so that's working, and in fact, so far, might need a little bit of fine tuning or debugging, which I will do. But so that's working with that keyboard. So now let's try another keyboard, one of those big ones. Okay, so here is an older USB keyboard, came from Lenovo, was a little mini PC, at least 10 years old. I never use it. And here, I thought that the pause button didn't work, but it does. So I stand corrected on that. But the numlock button doesn't return anything, and also the Windows button, which you can't see it off screen here, but it doesn't work same as on the other one. I'll be having a look at those things and see. But these buttons over here, they do seem to work. 7, 8, 9, 4, 5, 6, 1, 2, 3, 0, and dot. Okay, so I've got it working on this little board here. Notice that on the back of this board here, there's a little solder pad here that says USB-OTG, and in order to get the host port working on this, there's two ports there. One is actually marked USB, so to turn this USB port from an output rather to an input, you will solder a little blob over there, or a little wire, or whatever you've done. I in fact soldered the one that we're actually running. I soldered a little switch on it. A bit hard to show on this small There's a little switch there that I can switch over, so I can experiment without having to remove solder blobs. And then you can use this UART port over here. This one here will still work as to upload code and to actually use the serial monitor with, and this port will then become an input, a host port. And that is how I've got this one connected over here. Let me zoom out so you can see a little bit more. I've got two cables, and one is going to the computer, and this fat one here is going to the keyboard. And when I plug the keyboard in, let me bring up the keyboard camera. So when I plug the keyboard in, same thing, as you can see, it's being powered. Now in this case the power is coming from the computer, it's coming from the port over here, but there is another switch that I have put on here. There's another pad there that says for external power. So I would be able to plug in this little header over here. I could plug some 5 volts into the port over here and power it from there. But this one does not have any battery charging circuit. So, but in any case, let's look at the code. I didn't have to make any changes other than I removed some code from it. So I took out the TFT stuff. The platform INI, I just put in my different board here, ESP32 room, the board file that I made up for it. And it also has a pins file, but it is very different. This is the standard one that's in the Espressif ESP32 S3 folder. And it just has a bunch of it has these RX, TX, SDA, SCL, SS, MOSI, MISO, and S clock, and then it has all the analog pins that so you can use A0 instead of GPIO1, and touch pins, and that's all it's got. So we're not worried about any of those, we're not using that. So I actually took code out, and now we're actually printing to the serial monitor because there's no TFT display. And actually I can take even this comment out, actually, boom, because we're not doing that anymore. File, save, and I would be able to actually say upload. And as you can see, it is working there. And now when we go to the keyboard, and I will move this whole caboodle up so that you can actually see. Okay, that should be better. So we can start monitoring. And now if I hit a key, there's a Q, Shift Q, and insert, delete, page up, page down, arrow keys, and again, Win key doesn't do anything, and caps, tab, escape, they're all working. 2, 3, 4. And on this keyboard it's little, so I actually have to hit function in order to get F1, F2, F3, F4, and so on. F12. So that's also working. Now the question is, can we make it work with this little weeny one that only has one port? In fact, we won't be able to monitor this unless we wrote some code in order to output something to Bluetooth or something, or Wi-Fi, but that is another thing that we will have to do in the future, I think. In any case, we show that on the ESP32-S3 chips, it can certainly host devices. Of course, it's not limited to a keyboard. It could be a mouse, it could be a game controller, could be anything, because as you might remember, let's have a look in this. Let's get rid of the keyboard, don't need to see that. There's all these devices, some of which I don't even know what they are. Simulation controls, generic desktop page is one, simulation controls, VR console controls page. Maybe that'll work with those VR goggles and things. Sport control page, game control page, generic device control, keyboard, this is the one we're using, 07, LED, button, just keeps on going, medical instruments, braille, and so on. Scales, must be for weighing scales or something. Arcade page, goodness knows what all that is used for. So that is part of the official usage tables for serial bus. 1996 it was first done and updated in 2022, no doubt for the VR page or something. Okay, so I think that we have proven that this stuff works, so I think we might close this episode off with that. I was initially going to try to use it on that little device, but I think I will leave that until a next episode, because we're actually going to be creating, I'm determined to use this little Seed Studio one for a keyboard, and I'll be outputting stuff through Bluetooth, so I might as well do that properly in that in the next episode. So I will see you guys then, and don't forget to subscribe and ask to be notified when there's a new episode in this series. So we're going to be getting serious about using this stuff. I'm going to be debugging this interface. I want to know why the Win key and so on, some of them don't come back with a code. I want to see if that is a bug or if that is an actual reason for that. Anyway, I'll see you guys later.